it would definitely be on this. And that is the topic of key or core structures or fundamental structures in primary maths. So the first thing I need to do is clarify the difference between representations and structures. So the best way to do that is to look at a load of different representations together. So here I've got a 20 bead string in fives. I've got a couple of versions of a reckon rec, numbers to 20 in groups of 5. That's a soroban. That's a coat hanger with pegs. That's just handy here somewhere. What have we got here? Oh yeah, they're 10 frames and 10 frames in egg boxes, Hungarian number pictures, and fingers and toes. And the reason I put all of these representations together is to explain that they show the same structure. The numbers to 20 developing as 5s and 1s to show people that that's instantly recognisable as a 7. And it's probably easiest explained with tallies. So if I show you that, how many lines are there? That's pretty difficult to do, but if I turn it over and the lines are organised into this structure, it's 17, very obviously. So all of these representations are developing the same underlying structure of the maths. Some of them are doing a bit more as well. The soroban is, and some of the others are going off in tens and numbers to 100 as well. But when you start to distill out individual structures of maths, suddenly your understanding of how to teach effectively becomes much more efficient. So a lot of people get carried away. They get into Numicon and they see that as being the essence of things, and it isn't. We're going a level deeper, and Numicon is an access structure for array. So over the last 10 years, I've really come to believe that there are 8 core structures in primary maths, but this is just a hypothesis. I want to bring others into the conversation. I want there to be a real global dialogue on this. So this is where I've got to so far. It is based on a lot of work, but it is so contextual. So the number 1, these aren't necessarily in order, but I think I would probably always put this at number 1, although those who love Vasily Davidov may disagree. I'll come back to that later. Is the cardinality of number, and this is what we need to get children to understand on access to schooling, and it's why I think it's a crucial reason why so many children end up with profound number difficulties. And it's all about the idea that 4 is 4 objects. So that could be 4 or that could be 4. And recognising that some children think that that's 4, ordinal number, that 4 is an individual thing. And young children get very confused about this. And if we don't really sort that out at the beginning and give them an understanding that numbers are sets of things, and check that if we ask them to get 4 objects from a larger group, they can, then they're in trouble very quickly. And that can generally be fixed if we get it young. Hi, if you're watching, if you've got questions, you're welcome to ask them. I will interrupt and answer your questions, or come back to them at the end, depending on what they are, or just say hi. That'd be lovely. So that first structure is cardinal number. The second structure is the structure of 5s and 1s in the numbers to 20, which is really often neglected. The third structure, I think, is part whole, underpinning addition and subtraction. So you could do that with Cuisenaire rods, understanding that addition is the case where you know the 2 parts and you're trying to find the missing total, and subtraction is about finding a missing part. And that idea underpins counting on and taking away as methods of subtraction. And you can do that with the partitioning tree. You can do it, can start to combine structures. If I was looking at, say, 13, subtract 2, seeing it as a part whole structure. And a lot of the teaching methodology I do is based on combining structures to become aware of specific aspects of maths, or just focusing on one structure. And then the fourth one, and I think this is why people really failed to get to grips with fundamental structures, because we were missing a really good understanding of array as underpinning all multiplication and division. So if I look at an array like this, just draw it in. That array is showing 4 times 6 is 24. So we've got the numbers we're multiplying and the number of squares is the answer. But it's also showing 24 divided by 6 is 4 and 24 divided by 4 is 6. And it's actually showing both of those divisions in both ways, as sharing fairly and as counting groups. Probably come back to that another day because it's quite a big topic. But we can go to all sorts of places with that. In the Year 2 video I published recently, we were looking at arrays for odds and even numbers. And I recommend that video to you. It's had great feedback. Where's my board rubber? I'll just use my fingers. We can, when we teach tables, it's really powerful to use array packs rather than table squares to help children get to really deeply understand their multiplication facts and be able to puzzle them out rather than to rely on written facts dictated by someone else that they can't actually puzzle out for themselves. We can start to look at multiplication of fractions. So children in primary school could certainly have a go at something like 2.5 times 2.5 by the time they're about 10. And we can use it for array for multiplication, mental, long multiplication, and to underpin all thinking about. Hi, I'm back. Sorry, there's a slight glitch there. Lost connectivity for a little bit. So I've just explained array as structure number 4, although these aren't particularly in order at all. The next structure is the number line. And we start to introduce number line with pegged numbers and with the counting beads. But I think the crucial bit of work on the number line is actually developing children's understanding of continuous number. So when we move on to the counting stick, suddenly we have 11 numbers and 10 spaces. It's a different type of number system from discrete number where we're counting objects. It's the number of scales, it's the number of measure, and it's really important we lean into that, which is why I don't introduce it until Year 3 when I introduce it really, really thoroughly and carefully. Year 3 is age 7 to 8. However, that is controversial. Some people believe you should teach number as a continuous measure first. That's the Vasily Davidov that I was referring to earlier, and it's certainly an interesting theory. But within the current curriculum we're working with, it's not designed that way. So I focus on getting cardinal number established right at the beginning and bringing this in later, carefully and thoroughly. And then, of course, we go on to the open number line. Number 6. Number 6 here is base 10, and there are lots of representations of base 10. We've got, of course, the classic Deans, that everyone knows, but we've also got place value counters, and we have arrow cards, and then there's all the sort of hybrid representations. Got my bundles of straws here. And as ever, I have my fabulous penguins on ice. And I've got a few others down there as well. But just to show you that there are loads of ways of working with base 10. And it is, of course, fundamental for formal algorithms for the 4 operations and much more. And then we get on to proportion. And this really drills into how human representations are, because I think we need 2. We need a linear structure because our brain needs to decode linear proportion. Where have I got it? Let me just have a look. Somewhere I have a wonderful book of fraction walls that I meant to get ready for this. I wish I could just put my hands on it. I sent it from Singapore, from a lovely lady there. Where you flip over, it's essentially fraction walls we're talking about, but we generally do it with interactive tools because they're so versatile for exploring and comparing fractions, decimals, percentages, and ratio. as a secondary school teacher, I always, most lessons I had my proportion bar tool running in the background, and it's so fundamental that I built it into my logo, into my Authentic Maths logo, which I can't just put my hands on, but it's the green and yellow bar on the blue background, because it's when we first got interactive whiteboards, it was the very first app that everyone just went, wow, this is awesome. They developed loads and loads of apps for the interactive whiteboards, and that was the one that just made so much difference to teaching a proportion bar. So there is one on MathSpot, and people get confused about bar modelling. What's bar modelling about? Well, there's two ways of talking about bar modelling. One is as a part-whole model, which I just showed you with the Cuisenaire rods. And in that, we use bars of different lengths to represent different sizes, not necessarily in strict proportion. So the bars can become very long as we draw diagrams with them. But the proportion bar is different. With the proportion bar, the size of one is constantly controlled. So it's really a different representation. People get very confused about their bar modelling because there's such different things in there. So if you think about bar modelling as being, some of it's about part-whole, and some of it is the proportion bar, then it starts to make sense. And this proportion bar is crucial structure of maths. And finally, it's because we are human and we need to learn to decode what we see. I think we also need a circular structure of maths. So we start to see things like a third being that, because we wouldn't see, it's an important thing to see and understand, and it lays our foundations for the understanding of pie charts. So that starts to come in primary maths as well. And it's fun to work with circles and pizzas. It's certainly accessible to children. So what's not got into my top 8? Well, there's quite a lot of work in the years under 7 of building sort of foundational structures in the concrete that are going to lead into these. And I haven't explored that in tons of depth. And I haven't put in a number square, because I think you can get away without a number square. I don't think it's a crucial building block in the way these other structures are. But all this stuff is up for grabs, of course. Join in the discussion. Tell me what you think. What else? At the next stage, I think we are leaning towards beyond age 11, so age 12, 13. I think we need structures for scaling. And again, like with proportion, I think we need at least 2. I think we need children to be able to decode functions and the gradients of lines as showing different rates of change, and just be able to spot it and see it really clearly. I've always taught that at secondary. And I think we also need children to be able to interpret scaling areas, as in enlargements. And then when we've got those representations established, we can develop an understanding of reciprocals, and finally children can properly understand how to divide fractions and so on, which isn't on the primary curriculum because it's just not accessible through the structures that we've got or through the real, we could only do it really in the context of specific types of real life example. What else? Yeah, the work on functions, it was Maria Drushkova introduced me to papers on that, and I'm eternally grateful for that. So that's it for this week. I've got another year 2 video going live that I'm really proud of on fraction. Is going live at 9:30. Hi, if you're there, it'd be lovely if you said hi, or if you want to ask a question, fire away. Now's a really good time. Otherwise, I'm going to sign off in just a moment. I think that's it for today. I hope this starts a discussion. It is what I'm passionate about and want to talk about, and it'd be great if you could join in that discussion. Thank you. Bye.